Hi everyone, I'm Tufan and today I'll be presenting my analysis on the factors influencing hypertension incidence in Ontario. Talking about the context, hypertension is a leading risk factor for cardiovascular diseases affecting nearly 1 in 4 Canadian adults. Despite its prevalence, nearly half of those with hypertension are unaware they have it, leading to serious health consequences. A detailed analysis was thus conducted on public health data from Ontario, examining the impact of various lifestyle factors and socio-demographic variables on the incidence of hypertension over a 5-year period of 2015 to 2020. This analysis revealed at the end that physical activity and the proportion of racialized and newcomer populations were the most significant predictors of hypertension. To address these findings, targeted public health interventions are recommended, focused on promoting physical activity and addressing health disparities in racialized communities. Hypertension, often called the silent killer, affects millions in Ontario, with nearly half unaware they have it. This makes understanding the factors behind its incidence crucial for targeted interventions. These are the major objectives of the research. First objective is to understand how lifestyle related factors like smoking, alcohol use, physical activity, nutrition, and maintaining a healthy weight correlate with hypertension incidence. Second is to evaluate health equity by examining the role of the Ontario Marginalization Index. This index provides insights into social determinants that might influence hypertension rates, such as residential instability or racial composition. Third is to identify and analyze trends in hypertension incidence over a 5-year period. This is the step-by-step analytical pipeline for the research. Let's go from data collection. Data from Public Health Ontario was collected for this research. The consistency of data was managed by taking only the data of 2015 to 2020 from all the data sets in the Excel files. Also, the data cleaning was done to match the headers and the names of public health units in all data sets. Exploratory data analysis. Exploratory data analysis was done using Python libraries, which helped in uncovering initial patterns and trends of the hypertension incidence. A line chart and bar chart were used to see the trend and the top 5 public health units with highest hypertension incidence rates. Next is correlation analysis. This step was crucial in understanding the relationship between the outcome of interest, that is, the hypertension incidence, and various risk factors. Then comes statistical modeling. Based on the correlations, statistical model was developed to discover the association of incidence of hypertension with the independent variables, and multiple regression analysis was done using the ordinary least square method. The final step involved actionable insights from the analysis, particularly for public health interventions aimed at reducing the hypertension. This is the data overview for analysis. Hypertension incidence data. Age standardized rates of hypertension incidence from 2015 to 2020 was utilized across different public health units in Ontario, which provided a consistent basis for comparison over time and between regions. Health behavior indicators. The dataset includes comprehensive measures of health behavior such as physical activity, nutrition, and overweight data, and the substance use data like smoking and alcohol use that is tracked over the same period. This alignment allowed us to explore their potential impact on hypertension rates. Health equity measure also was used. The Ontario Marginalization Index was integrated based on the public health units to assess how socioeconomic factors might influence hypertension incidence, ensuring that the analysis considers health equity and the broader social determinants of health. In this slide, I'm illustrating the hierarchical structure of the data used in my analysis by organizing it into different dimensions and the corresponding features within each dimension. At the top level, we have the main data dimensions that categorize the various types of data, lifestyle factors, socio-demographic factors, and health outcomes. These broad categories help us understand how different types of data are grouped based on the nature of the information. Under the lifestyle factors, we have features like physical activity, nutrition, weight, smoking, and alcohol use. These are critical behavioral factors that can influence an individual's risk of developing hypertension. Next, under socio-demographic factors, there are key elements such as racial composition, income level, and housing. These features highlight the socioeconomic and demographic conditions that may contribute to the health disparities across different populations. Lastly, under the health outcomes, we focus on hypertension incidence, which is the primary health metric of interest in this analysis. This line chart shows the overall trend of hypertension incidence over this 5-year period. The trend of incidence in this set of data is in decreasing order, which is a good sign. The incidence rate has significantly lowered in the year 2020. The bar chart shows the first 5 public health units with highest rates of incidence of hypertension within this period. The Peel Public Health is the public health unit with the highest incidence rate. These public health units should be given special attention during the public health interventions and in the policymaking strategies. Correlation analysis. We started with Pearson correlation analysis to explore the linear relationships between key risk factors like smoking and physical activity with hypertension incidence. This step provided in the insights initially on the relationships between the dependent variable, that is incidence rate, and the other independent variables, that is the risk factors. Also, the variance inflation factor VIF was used to check multicollinearity between the variables. Some variables showing multicollinearity were omitted. Going to regression modeling, multiple linear regression was done. This technique allowed to see the effects of each risk factor, ensuring that the findings were robust and reliable. Also, the Ontario Marginalization Index was integrated into this regression model to understand how socioeconomic disparities contribute to hypertension rates, emphasizing the importance of health equity in our analysis. These are the results generated. Let's go to the physical activity rate. There is a significant negative correlation between physical activity and hypertension. This is statistically significant with a p-value below 0.05. Racialized and newcomer population. There is positive correlation with racialized and newcomer population. This relationship is also statistically significant. Other factors. The weaker correlations were observed with other factors like overweight rate, nutrition rate, and the housing from the marginalization index, indicating that these factors play some role, but they are not as strongly associated with hypertension as physical activity and racial composition. Let's go to the model fit. The R squared and adjusted R squared values indicate the model explains a substantial portion of the variation in hypertension incidence, that is 63.8% and 55.2% respectively. This confirms that the overall model is statistically significant. To validate the consistency of the results, other papers were also compared, which also show that physical activity is highly associated with reduction of the hypertension. These are the key takeaways. Let's talk about physical activity. Public health policies should focus on promoting the active lifestyles through community programs, awareness campaigns, and infrastructure that supports physical activity. Addressing health disparities in racialized communities is also very important. Higher hypertension rates in these populations may be linked to the socioeconomic factors, access to healthcare, and other systemic issues. Targeted health interventions such as community outreach, culturally tailored health education, and improved access to healthcare services is recommended. And factors like overweight, nutrition, smoking, and housing were analyzed, but they did not show statistically significant effects in this model. However, they should not be disregarded as they might still influence hypertension under different circumstances or in combination with the other factors. Overall model insights. The model explains a substantial portion of the variation in hypertension rates, that is 63.8%, which underscores the relevance of the included variables. This also means that the other 36.2% is influenced by other factors that we could not consider here. Consideration of these findings in public health strategy planning is highly encouraged. These are the assumptions and limitations while carrying out this research. Starting with the assumptions, it was assumed that the age standardized incidence rates of hypertension across public health units were consistent over time. Second, accuracy of self reported data. The data on physical activity, smoking, alcohol use, and nutrition were largely self reported. So it was assumed that these self reports were accurate. Moving on to the limitations. Cross-sectional design. This study is based on cross-sectional data, which captures a snapshot in time. It limits the ability to establish cause and effect over time. Next, there may be other confounding factors that we did not account for, such as stress levels or environmental exposures, which could also influence our results. Next one, limited scope of socio-demographic variables. This study did not cover all possible socio-demographic factors like income, education, and access to healthcare. These assumptions and limitations should be kept in mind when interpreting the results or when applying the similar approach in future researches. Let's go to the conclusion. First, our analysis revealed that physical activity is a significant protective factor against hypertension. Regions with higher physical activity rates consistently showed lower incidence rates of hypertension. This finding underscores the importance of promoting physical activity as a key public health intervention to combat hypertension. Second, the study found that the racialized and newcomer population is significantly associated with higher hypertension incidence. This also suggests that the racial and ethnic disparities play a crucial role in the burden of hypertension. Public health strategies need to address these disparities through targeted outreach and culturally sensitive interventions to be effective. Third, while other factors like overweight rate, nutrition rate, smoking rate, and household or dwelling density were analyzed, they did not show statistically significant effects in our model. However, this does not mean these factors are unimportant. It may indicate that their effects are complex or require further investigation with different methodologies. Considering these findings, public health policies should prioritize increasing physical activity across communities and addressing the health equity, particularly in the racialized populations and in those public health units with highest incidence rates. By focusing on these key areas, we can make substantial progress in reducing the burden of hypertension and improving cardiovascular health outcomes. In conclusion, this project demonstrates the power of data analytics in healthcare. Physical activity and marginalization are key factors influencing hypertension incidence, and addressing these could lead to significant improvements in public health. Thank you for watching. Feel free to reach out if you have any questions or want to learn more about my work. I'm passionate about using data to drive impactful decisions. With my skills in exploratory data analysis, regression analysis, and data visualization, I look forward to contributing more meaningful projects. So I'll be happy to connect and collaborate. Thank you.